All right, let's graph exponential functions. So the first example, let's do f of x equals 2 raised to the x power. All right, so let's find the initial value. So again, the initial value is the y-intercept, or f of 0. So if I find f of 0, I'll put 0 in for x. That would be 2 to the 0 power. So in the last lesson, we learned that anything except 0 raised to the 0 power is 1. Right, so the y-intercept should be at 1. Alright, let's find f of 1. So if I put 1 in for x, that would be 2 to the first power, which would be 2. So I'll plug in a 1 and I get a 2. F of 2, so that would be 2 squared, or 4. And let's just work out some more of these. F of 3 would be 2 to the third, which would be 8. F of 4 would be 2 to the fourth, which would be 16. And let's plot those. So if I put in a 2, I get a 4. If I plug in 3, I get 8. And if I plug in a 4, I get 16. And then you can see it starts to go up really fast. If I put in a 5, I'll get a 32. If I put in a 6, I'll get a 64. So it's going up really quickly. What about fractions? So f of 3 halves. So that would be 2 to the 3 halves power. In the last lesson, we learned what this meant. So this would be the second root of 2, or the square root of 2, raised to the third power. Well, the square root of 2 is about 1.4 approximately. And 1.4 to the third, we would get, so I checked my calculator here, cheated a little bit. That would be about 2.8. So let's see if that makes sense. So if I plug in 3 halves, that's 1.5, so that would be here. There's 3 halves, and the answer should be 2.8. There's 2.8, and it's about there where it should be. So good. So you can plug in all of these numbers for x. So I'm allowed to connect all these dots. Our graph looks like that. All right, what about negative x values? So let's plug in -1. So that would be 2 to the negative first power. Again, last lesson we learned what negative exponents meant. So that means 1 over 2 to the first, or just 1/2. So if I plug in -1, I get 1/2. Should be about here. Okay, if I plug in -2, that would be 2 to the negative second. That would be 1 over 2 squared. Would be 1/4. And 1/4 is a little bit less than 1/2. So it should be about here. F of -3. So that's 2 to the negative third power. 1 over 2 to the third, which would be 1 over 8, and that's less than 1/4, so that would be here. If I plugged in -4, I would get 1 over 16, which would be really close to the x-axis. And you can see what's happening. The farther out this way I go, the closer the graph will get to the y-axis. So for instance, if I plug in negative 100, it would be 1 over 2 to the 100th, which would be a tiny little number, just barely above 0. So what happens is we get this horizontal asymptote out this way, and the graph will keep getting closer and closer and closer to that asymptote, but will never touch it. All right, so you guys are familiar with pi. So most of you know that pi is approximately 3.14. Remember that pi is an irrational number, which means if you wrote it as a decimal, the decimal expression of it would go on forever and ever and ever. So these digits just keep randomly occurring forever and ever and ever. So pi is equal to 3.141592654, and you could keep doing those digits forever and ever. And then you just round it off, and you can say pi is approximately equal to 3.14. Okay, so e is also an irrational number, probably not one that you're as familiar with. So e is just like pi. It's an irrational number whose decimal representation goes on forever and ever and ever. These random digits. Okay, so you could say that e is approximately 2.7. For our purposes in this lesson, we're just going to say that e is a number between 2 and 3. So as long as you understand that e is between 2 and 3, you will be able to graph the exponential functions that we're concerned with for now.